The ocean is suffering. Coral reefs, the rainforests of the sea, face rapid decline. In Japan, cutting-edge robotics and AI are stepping in to help heal what nature alone is struggling to restore. Coral reefs cover less than 1% of the Earth's surface, yet they support an estimated 1/3 of all marine species and underpin a multi-trillion-dollar economy. But rising water temperatures, pollution, and ocean acidification are decimating reefs worldwide. 90% of reef ecosystems could be lost if global average temperatures rise by 1.5 degrees Celsius. Japan's Okinawa region is home to 400 species of reef-building corals, many under threat. While manual coral planting can help, the scale of loss demands smarter solutions. In Japan, researchers are turning to robotics and digital twin technologies to restore reefs at scale. High-tech underwater scene showing a sleek, autonomous underwater vehicle, AUV, equipped with LiDAR scanning equipment moving through crystal-clear water. The robot's sensors emit blue scanning beams that map the seafloor in real time. Fujitsu logo appears subtly in the corner. The camera follows the AUV as it navigates around coral formations, its advanced sensors capturing detailed 3D data. For example, Fujitsu announced a field trial of underwater drones and LiDAR-equipped AUVs that create highly accurate 3D models of coral reef locations near Ishigaki Island, Okinawa. Meanwhile, the Okinawa Institute of Science and Technology, OIST, is using genomic analysis and eDNA to identify which coral species to plant where and monitor their impact. Here's how it works. Autonomous underwater vehicles map the seabed, capture high-resolution imagery, and assess damage and coral health. AI and image recognition tools classify areas needing restoration and select optimal sites. The robot moves with mechanical precision, its manipulator carefully positioning each coral piece. Small LED indicators on the robot glow as it completes each planting operation. The scene shows the intersection of advanced technology and delicate biological work. Robots, or remotely operated arms, plant coral fragments or seedlings precisely in the right spot, reducing waste, improving survival. For example, IoT and AI systems are already being used in Japan to manage coral seedling aquariums, replicating seasonal cues, spawning, and growth before outplanting. On the ground, or under the sea, this is changing things. At OIST's planting sites in Okinawa, such as Henza Island and Azama Sunsun Beach, new coral fragments are being introduced into reef systems with scientific oversight. Local startups are also involved. For example, Inaqua Inc. uses IoT plus AI to cultivate coral ecosystems in tanks, preparing them for ocean planting. This is ecosystem restoration at a scale humans alone could never reach. Technology aiding nature, not replacing it. Of course, there are challenges. Robot deployment and deep-sea/strong current operations remain complex and costly. Coral survival depends not just on planting, but on broader reef health factors: water quality, temperature stability, biodiversity. Monitoring and long-term maintenance are key. The tech may plant, but nature must sustain. Japan's tech is promising, but restoration is a marathon, not a sprint. When robots help heal reefs, we open up hope for our blue planet. Japan's approach shows a blueprint, a blend of robotics, AI, genomics, and on-the-ground community action. Using tech to revive coral means preserving marine biodiversity, protecting coastal communities, and keeping ocean ecosystems alive for future generations. Technology rebuilding ecosystems, one coral at a time. Join us in supporting innovation for the oceans. Subscribe, share, and follow updates on how robotics and marine science are teaming up to restore the seas. Because the future doesn't have to lose its reefs. We can help nature heal. #RobotsRestore. #Coral Reef Restoration. #Japan Tech. #Marine Conservation. #Blue Planet.